तो आज की क्लास में वी विल डिस्कस के वन ऑफ द पास्ट एग्जामिनेशन पेपर्स दैट इज फ्रॉम April 2021 and we will be discussing that how we will proceed with the paper and like what all things we have to keep in mind while giving the paper. So first of all, the paper will be of 100 minutes and you will be given 105 minutes, so that is approximately 1 minute per mark, not per question, per mark. So whenever you are getting the question paper, just divide your time accordingly, because like there can be cases wherein the question is very easy and you fall into a prey that like let me attempt this question first, and you take a lot of time in that particular question. Like let's say we are getting 4 questions and the weightage is like 10 marks, 20 marks, and then rest of the 2 questions are having most of the weightage. But you start with the question that is that belongs to 10 marks, and you divide your time according to the questions rather than the marks. So you have to keep in mind that if there is a question worth 10 marks, you have to spend just 10 minutes for that particular question. So that is something that you have to keep in mind before starting your exam. Just go through the complete question paper when you like get the paper, and after that evaluate that which question will take very less time for you to like complete. So if you are confident in some topics, so we all are confident in some topics, and in some topics we might take up a lot of time, or more time than the other topics. So for those topics, what you have to do, you just have to basically attempt those topics in the end. So do them towards the end, okay? And like no cheating and nothing has to be done, and like you have to be honest to yourself, and there are a lot of tracking mechanisms, so don't think about such practices. And let me just open up the question paper and then we can discuss it. Let me just open it up. Okay, so you must be seeing the paper now. So here if we talk, so this is the question paper for April 2021, okay, and this is the first question. So you can just like according to me, if I just talk about the level of difficulty of this particular exam, so it was like till now, so even it is even simpler than the first exam that happened after the change in the syllabus. So this is a very basically easy to medium level type of exam, and it is a very scoring one. So it is very easy for you to score above 80, above 90 if you just spend like some time in learning what all has been taught in the classes. So like you will just feel that all the questions that are there in the exam, so they are like in one way or another they are talked about in the class. So herein you can see, so the first part is you have to just insert the data. The code for insertion is also given to you, and we have to plot a scatter plot. So just plotting a scatter plot worth 2 marks, like it is like dirt cheap money, or dirt cheap your marks. So it is basically very easy to score, and after that you have to comment on the relationship between basically 2 points that you have in scatter plot. We'll just come towards the answer and discuss like how we can interpret and how we can see the other things as well. And mostly the parts in which you have to do comments, you have to justify your answers in the part like these. So it is most of like it is mostly related to your CS1A, and you have to just see the interpretation. We are like learning about the interpretations from the 11th 12th standard, and we just have to interpret our results, and it is mostly being taught in CS1A only. So here nothing related to R. So if I see this question, so it is total of this question is 15 marks, and we will just see that how many lines of R code we have written here. So let me just open up the okay. So just like this is the graph. See, it is easily visible that like this is exponential relationship, negative relationship between the two variables, time and caffeine. And after that, like one line to plot this scatter plot, or then you have to just take the log, like one line for taking log, and you're just printing. So I'm not counting the lines in which you are printing. So one function, basically log function, and one function to plot your scatter plot, and then another one function wherein you are plotting the logarithmic values. Okay, so 3 lines of code as of now. Then you have to find the correlation, 4 lines of code, and done. So there were just 4 lines that you had to write that belong to R and not your CS1A. So people who think that these 4 lines are difficult, then like there is nothing else that you can do. Basically this is like something which is very easy. So even the exams that we conduct in your like curriculum while you are learning, so mock papers that we have, they are more difficult than what is here. So believe me on this thing. So let's go back to the exam. So first question is like 15 easy marks. Anyone who has very basic knowledge of R can like score these marks. So it is very easy for anyone to score these 15 marks. Let's move ahead with the question number 2. So like for the question number 2, if you read out the question, so an analysis was carried out to investigate the fairness of 2 exam markers. They both mark the same 150 exam papers with 10 questions and total possible marks of 100 for each exam paper. The data we collected and arranged into 10 equally spaced groups with marks rounded to nearest whole numbers. So these are the marks that are given. So this is like, I think I have seen it for like I think first or second time that they are giving the code to insert your data. So it will help you to save up time. So you can just copy these lines, you can paste these lines in the R Studio, as we like code everything in R Studio as taught in the classes as well. So you can just copy and paste the lines, you don't have to manually enter the data, and try to just copy it and not manually entering it, because whenever you will be manually entering the data, there are chances that you might miss some of the data that is here. So like preferred way is to just copy this line and paste it. And then you have to plot 2 graphs for each marker. So it is just plotting, you have to plot mark 1 and mark 2, and after that and they are like they have not mentioned the type of graph, I think, yeah. So they have not mentioned the type of graph, but they have given a hint. You may find the R command bar plot useful. So they are hinting you to use a bar plot to plot this data. And after that they want you to comment on the graphs produced in part 1A. So basically you have to look at the 2 graphs. One graph is having the bar plot of first marker, and second graph is having the bar plot of second marker. And according to that, what you have to do, you have to basically look at them, you have to analyze them, and then you have to comment on the findings that are related to those 2 graphs. We will see how we are like what is expected in these findings. So we will see very shortly. Let's first like read the current complete question, and then we will be looking into the solution to this. So like 7 marks for just 2 plots and some comments. So I don't think it is difficult for anyone. So yeah, if you don't know what to comment and how to analyze the graph, so that is something that is beyond the scope of R as a syllabus and as a whole. So it is something that you will have to learn separately when you are learning your CS1A, and like B is just using that concept. Okay. So one of the marked exam paper is selected at random, and the scores given by each of the markers are analyzed further by question. Below are the scores given by each of the exam markers for this selected exam paper for each of 10 questions. So herein there are like one of the marked exam paper is selected at random. Okay, so one of the paper was like some of the papers were selected, and again there are some random like observations that we have. So they have again given you like the code to copy the data into your R Studio. Just copy and paste that code. Perform a suitable test to determine whether the difference in the mean scores of the two markers is 0 or not. So all of those who have attempted like the initial classes wherein like after the basic R we started the CS1B. So if you have attended the first 2 classes, you will be able to, like, you are in a very good position to do this question and score these 5 marks. So till here, if I talk, like 15 marks for the first question and approximately like 12 marks here. So approximately 30 marks, and like there is nothing exceptional that you had to do. If you have that basic knowledge that is being taught, so these are like very easy marks. Perform the test specified in part 2, ignoring that 2 markers have marked their same exam paper. So basically the part 2, it is like urging you to like use the paired t-test, and in the part 3 they want you to like remove that assumption that the data is paired. So you will be performing simple t-test, and then you have to comment, like again you have to comment on part 2 and part 3. So paired t-test and simple t-test, so you have to compare those 2 basically observations, and then you have to comment on it. Comment on the issue arising when analyzing paired data as independent sample and independent samples as though they were paired. So basically if we see 4 marks here, and in the 5th part 2 marks in the 4th part, and then let's say that like in the first part there are 2 parts, so if we divide it equally, so 3.5 marks here, so approximately 4 and 4, 8 and 10 marks in 22. 10 marks are just for you to comment on the observations. So basically if we have a look at the solution for this, so here we are just using bar plot. We have plot the data. Here are 2 bar plots that we have. Okay, I think the screen hung up. Let me just quickly yeah, so answers are visible to you. So we have basically two bar plot commands. So here are 2 bar plot commands, and then like this is some analysis. So this distribution of marks looks similar, especially for the middle score. However, that appears to be some difference in the marking for low and high scoring exams. So basically this is the analysis that they have given, 1 mark for this. The plot of marker 1 resembles a normal shape, but it is not as clear for marker 2, where there appears to be some skewness. overall the plot suggests that the two markers are generally consistent. So you are getting these marks like for free for just like doing the analysis from the bar plots. And after that, so they have asked you to basically do this t-test, and as you can see, so yeah, so as you can see, so here is this parameter paired equal to true. So this is used in the paired t-test. And if we talk about the third part, so here we have not mentioned any marker here. So this is something that we had to do the paired t-test and the simple t-test. So these are the two things. So here you are getting the marks for just writing this single line. So this is the single line that was there for the R code, and in the second part also this was just one single line. Okay. And after that, from the observations, so there are some like some of the observations that you will have to make from these deductions, these t-tests. So part 2 and part 3 lead to different conclusions. We would expect the data to not be independent of one another, since both markers have marked the same exam paper. So one more thing, so I am not going into detail for the basically comments that you have to put, because that is something that out of the scope and purview of what we are discussing right now. So we are more focused towards like what like how you have to interpret the questions from the R point of view, and this is the interpretation that like you have to make on the basis of like what you have studied in CS1A or either 11th or 12th class. Okay. So one thing that basically you will observe is, so if there is something that is mentioned here, so you don't have to write it in a very same and exact way. So the way you are writing it, it can be different, but basically you don't have to write the exact same language. Like you might have some different words to write. So it is not important that like you have to choose the exact same words which examiner wants to hear, but the observation has to be same. So it is not the case that you can like if you are writing something else and the observation is asking something else, so the marks will be deducted for sure. Okay, so you have to keep in mind that what is asked in the question, and you are just like writing your observations towards that point. Okay, so these are just like free marks for you. So we have discussed 2 questions as of now. So in these 2 questions, if we talk about 22 marks and these 15 marks, so approximately 37 marks, and I cannot even count the 10 lines of R code. If like I have not written the 10 lines of R code, and you have like just obtained 37 marks out of 100. It is as easy as that. So let's move to the third question. Third question is, a study was carried out to estimate the proportion P of workers that commute by train to work. A total of 200 workers were sampled at random and were asked the question, do you take the train to work? Okay, so basically there is some data. Now like many of you, so we have also discussed in the doubt class. So if we are having basically this type of file, .r data file. So you have to double click on this file. It will just open it up in your R studio. Or there was a function, if you remember, we discussed in the doubt class, there is a function called load, and you have to pass the path. Okay, so this is the file, like you will have to call a function load, and then you will have to pass the path of the file into that function, or you can just double click and it will open it up in R studio window. Okay, so this way you can open up this file, and so this is something that we already covered in the doubt classes that we had. So Alice assumed so 2 commuters, Alice and Norman, were interested in the study and proposed different prior distributions for the proportion P. Alice assumed a discrete prior distribution GP given the following table. So values of P and GP are given to you. Norman chose to use a beta prior distribution for P with parameter 3 and 12. So there are basically two type of prior distributions that are given to us. Calculate the mean and standard deviation of Alice prior distribution. Okay, so it is like for Alice we have the data with us. We just have to calculate the mean and standard deviation. If we just have a look at the answer, so that you are like aware like how why you are like offered so many marks for free. So you can see, so this is the code. You have just inserted the data. Okay, in the first two lines you have just inserted the data, then you have just calculated the mean, that is P into GP, sum of P into GP, and for this basically deviation you are doing the square root minus mean. So these are just the formulas that you have to apply, nothing related to R. So we already know that there are two SQRT, square root function. We know like caret sign, it is used for calculating powers, and then what you have is you have just like you have to use these two functions, and rest are all the formulas. But like if you cannot do this, and if you don't know the formula, that R is like just a medium, it cannot tell you the answers on its own. But yes, if you know the formula and you know like what are the basic functions of R, you can easily attempt this question. Let's jump back to the question. Yeah. So after calculating all these things, so B part is generate. So it is worth 4 marks, free 4 marks. Generate 1000 random values for Norman prior distribution. So Norman's distribution was beta distribution. So you have to use R beta function to with the parameters 3 and 12 to calculate 1000 variables. So they can say that generate 1000 random values. They can say simulate 1000 values, 10,000 values, or like they can say that it using bootstrap method generate 1000 values. So they are all the same thing. Calculate the mean and standard deviation of the value generated in part first B. So now for these random variables you have to calculate the mean and standard deviation, that is the same thing. So you can use the mean function if you are having the values, and SD function for standard deviation, and then comment on whether or not Alice and Norman have same prior beliefs for P. So comparing the mean and standard deviation, you can easily say if they have the same belief or not. So same belief, if they are like they are close, so you can say that it is the belief is same, and you can justify your answers by like writing the proper lines. We will not go into the details of the comments that we have to put. So if we say this is worth 10 marks, part A, part first, and like you can just see that how easy it is to score these marks. Norman's beta prior distribution for P is adopted for the remainder of questions. The likelihood of the model in the study is given by this. So you are given the likelihood function, and the posterior density of P is given by a function this. So you have like these two things, likelihood and posterior density function, where sigma yi is the total sum of all the binary data. So binary data is the data that you have. So binary data is basically yes or no. So it is mentioned in the question. So they were asked single question, do you take the train to work? So answer will be yes or no. So it is binary data because it is just having two outputs, either yes or no. And then we have plot the shape of posterior density P without identifying it. So basically you don't have to identify that whether it is beta, gamma or what. You just have to plot it and identify the shape. So let's see. So let's check the other third part as well, and then we will move to the answers for this. Plot the density of Norman's prior distribution by setting y limit. Okay, let's move to the answers now. Yeah, so you have read the data. So here you can see that they have used for R data. They have used the load function. So I think if you are able to see my screen again, so something went bad. Let me just quickly correct it up. Yeah. So here we are back again. Yes. So I think the data is visible to you. Yeah. So here you can see that they have used the load function here to load the data, and after that, so they have like calculated the plot and density functions. So here you can see that they have just created the formula out of the function that you are having. Okay. So here dense is equal to p to the power 2 plus some y. So it is similar to what like what was mentioned in the question. Okay, and then they have plot like they have used the plot function to plot this data. So it is plotting like this, and after that for the prior distribution, so we have created this plot function again for the prior distribution. So that is beta distribution for Norman, and yeah, I think it was here till here only. So we discussed about like part 2 and part 3. So we are just plotting the data for the two different distributions. So let's jump again and let's see the question again. Okay, so we have done the plot for posterior without identifying it. So we have just created the plot, and we can identify that it is close to the Norman's distribution, but the peak is very high. Okay. So the posterior distribution of P is beta with parameter 3 plus summation of yi plus 12 plus n minus summation yi. So plot the posterior density of P by adding it to the plot in bar part 3. So here they are asking you to plot this density function onto the plot that was created in the part 3. So you have to you have to superimpose that basically. So you will be using the lines function to plot this data compared to densities. So comparison is something again that you have to analyze and comment on it, and then comment on the extent to which the posterior distribution is affected by the prior distribution. So basically this is something again that you have to analyze. So nothing no R part here. Determine a 90% interval estimate for P based on the posterior distribution. So you have to calculate the 90% interval. So here you can use the quantile function as well. So let's see part 3 A, B, first part, second part we have already done. So posterior distribution, basically they have plotted the beta distribution here, and like here we talked about superimposition. So this was the red line was the the data for the the function that was given, and the black line, dark line, so it is basically your beta distribution. So you have created these two plots and superimposed it. Clearly the posterior is much narrower than the prior distribution. The posterior distribution is more affected by the data than the prior distribution. Okay, so these are two analysis points which will be fetching you 2 marks each. Then you have to calculate the 90% interval for P, and you can use either the quantile function or Q beta is already calculating the quantile for the beta distribution if you pass the parameters. So here in the parameter section you can see that this was the first parameter and this was the second parameter. So they are both calculated and converted into a formula, R formula, and they are passed here. Okay. So you can see that it is not at all difficult, not at all. So it is very easy, and you just have to learn the basics very well, and basics are being taught to you in a very good way. And we have also discussed about each and every doubt in the doubt classes. So I don't think that you will be facing much problems if you are getting these kind of questions in the exam. So determine, so we have done this, determine the exact posterior probability of P that exceeds 0.25. So again you have to use 1 minus 75%, and then you can calculate this. We have done similar questions in our second or third class that we had. Generate 10,000 samples for the from the posterior distribution of P. So you can generate samples from beta distribution. calculate the proportion of sampled values of p that exceed 0.25. So here you have to manually calculate that how many values are exceeding 0.25, and then compare your answer with in the part 7th B with your answer in part 6. So here for one thing is that you calculated with the formula, then you had the actual data. Now you are calculating from the data. Now you have to compare these two values. So how they are in the how far they are or how close they are. So you have to just analyze that part. I will not discuss this thing because it is like I think it is very easy. So we don't need to look into the answers for this. So like it is something that is very self-explanatory. So 28 marks for this, like this easy question, 28 marks. So like most, like 75% of your paper is done, and like there is not even a single thing that we have not discussed in the class. So let's jump to the question number 4. A statistician wants to model the number of passengers boarding a bus from a bus stop close to student residential area. They can think of 3 explanatory variables: which route it is at 8 am or 9 am, if it is during the semester or not, or the temperature in degrees Celsius. The statistician had data for 20 days given in the file named as CS1 passenger.rdata. So here again we are having the rdata file. So you have to double click or use the load function to load this file, and believes that the response variable passenger follow a Poisson distribution. After loading the data into R, the frame data passenger. So after like you have loaded the data, you will be getting this as a variable, data underscore passenger. So if you write this in your R console, data underscore passenger, you will be getting the passenger data with the 3 variables: passenger, route, semester, and 4 passenger, route, semester, and temperature. State the linear predictor corresponding to the model specified with the following R code explaining all the relevant terms. So basically here what you have to do, basically if you are mentioning temp plus semester, so what all variables will be counted? So it will be temperature, semester. If it is temp into semester, it will be temperature, semester, and temperature and mixture of temperature and semester. And if you are writing temp into semester plus root, so it will be temperature, semester, temperature, semester, and root. Okay, so this will be your approach. So let's also see the answer so that you can understand what I have just talked about. Yeah. So here you can see, let's see the alternative answer first because it is easy to understand. So here you can see A, B, basically here in, yeah. So it was, the first was temperature plus semester. So B1 is like, let's say B1 is temperature, B2 is semester, okay, or X1 is temperature and X2 is semester. Here second was temperature into semester, so temperature, semester, temperature, semester. Okay, and third was temperature into semester plus root. So temperature, semester, temperature, semester, and root. So these are the different variables that will be used in the explanation of the model. And after that, you are asked fit a Poisson generalized linear model. So you have to use the GLM function. Like it is very direct question, so you have to use the GLM function. It is Poisson, so you can use the link function of Poisson and model the data. Basically that is it. So it is worth 6 marks. You have to then comment on the significance of the parameter that we have already discussed in class. Let's open it up again and let me just show you. Yes. So GLM link function is Poisson function, and you can just see. So this is the code to write the GLM function. Okay, we have already discussed this, and like there is no point of discussion here to discuss this particular function, because like there is nothing new that is done here. It is just a plain simple GLM function. So it will be giving you this thing, and this star and this dot here, so they are signifying something. So significance code, they are written here. So we know if we are having more stars, that means more significant. So let's say yeah, so in the part B you have to talk about the significance. So temperature is significant, it was star here, star there already. Semester is not significant, root is not significant, the interaction between the temperature and semester is not significant at 5% level, but is close to being significant. So you can see that this is significant temperature. Here you see nothing, so it is not significant, not significant. Here you see dot. Dot means it is close to 0.505 significance. Like it is very close to being significant, but it is not very significant. So you can just remove these two, and you can keep this one, and you can keep this one also. Okay, so this is what it shows. So let's move back here. Fit an improved model for the model in part 2A using the answers in the part 2B. Label this model as model 2. So basically here you have to like remove the variables that are not significant, and then you have to recreate a model, and then you have to justify like if the model is improved or not. So this can be this can be proved using the p-values, area under the curve, and the measures like these. Okay, so this we have already discussed in the class, how we can compare two models. And then you are given a new model, model 3. So herein you are given a new model, and this model is like you are also given the code for this model, and then demonstrate that model 3 outperforms the model defined in part 1A and 2. So basically here also you have to compare these models. So after compare, like you have to compare the model 1, model 2 and model 3, and after comparison you have to come to a conclusion that why model 3 outperforms. So you have to look at the parameters like what are the statistic values, what are the AIC values, and then you can comment on this thing and draw a suitable plot for the residuals. So from any model you can use the residual functions to take out the residuals. Then you can use the plot function to plot that part, and you have to comment on the residuals. So basically you have to see that in which range they are lying, are there any outliers or not. So that can be analyzed from the graph itself. And then calculate the predicted number of passengers for an 8 AM route during the semester at temperature of 0 degree Celsius and model using model 3. So this is something you can use the predict function. We already discussed this thing in the class, and it takes up a data frame. So first you will have to create a data frame. So you will create a data frame. You will put the values of temperature 0 degree and route is 8 AM in that data frame, and then you will pass that data frame to the predict function, and it will just give you some value, and then you have to use that value. Let's quickly see this. So herein you can see that they are using the AIC as a criteria to judge the models, and then you have to plot the residual. So here they have used it directly. You can use the residual functions as well. Okay, and then the analysis is residual plot shows no pattern, exhibiting a fairly random scatter around with the zero constant variance, around 0 with constant variance and no outliers. And then for the predict, they have created a data frame here. They are passing the model, that predict model and data frame. So we have discussed how to use the predict function in the class itself. So easy, very easy paper, and you are getting 35 marks. So it is very easy to score if the paper is like this. Very easy to score. And believe me, if you you understand the basics of basically R and then CS1B, you will be able, you are in a very good state to answer all such questions. Okay, so I think with this we can stop this session, we can end this session, and if you still have any doubt, we can you can contact the institute, and then we can talk about it. Thank you.